If you look at a clock, it feels completely normal that the hands move this way, to the right in a circle. We even call that direction clockwise, as if that's just how time is supposed to move. But have you ever stopped to wonder why? Why not the other way around, like this? Well, the answer goes back long before clocks even existed, to the very first device humans used to track time, the sundial. A sundial is incredibly simple. You take a stick, called a gnomon, and stand it upright in the ground. As the sun moves across the sky during the day, the stick's shadow also moves, sweeping across the ground like the hand of a clock. And based on where the shadow is on the ground, you can tell what time of the day it is. Now, imagine you're standing in Europe or anywhere in the northern hemisphere. In the morning, when the sun rises in the east, the shadow of that stick points roughly west. As the sun climbs higher, moving through the southern part of the sky toward the west, the shadow slowly moves across the ground from left to right, from west to north. By evening, when the sun sets in the west, the shadow points east, now on your right side. In other words, as the hours pass, the shadow on a sundial moves from left to right, exactly the same direction that we now call clockwise. But if you were standing in the southern hemisphere, everything flips. There, the sun passes through the northern sky. So the shadow on the ground moves in the opposite direction, right to left. That direction isn't random. It's a direct result of the Earth's tilt and the way it rotates. The Earth spins from west to east. So the sun appears to move across the sky from east to west. If you're north of the equator, the sun's path always curves through the southern sky. That's what makes the shadow move in that left to right arc. But here's a question. What's a sundial got to do with a clock? Well, the connection between sundials and modern clocks is pretty direct. When clockmakers in medieval Europe started building mechanical clocks, huge, gear-driven machines inside cathedrals, they needed a way to show the passage of hours visually. And they modeled it on what people already understood, the movement of a sundial shadow. So when they made the clock hands rotate, they designed them to move in the same direction that the sundial's shadow moved, left to right, or what we now call clockwise. If clocks had been invented in Australia or South America instead of Europe, our normal might have been the exact reverse, and what we now call counterclockwise would have been clockwise.